Imagine waking up convinced one ordinary food choice could quietly erode your strength over time. That fear has a name, a shape, and a familiar villain you already recognize. Soy. Not alcohol, not sugar, not aging, but soy whispered about in locker rooms everywhere. You picture man boobs, fading drive, softer muscles, and mirrors refusing to reflect authority. The story feels believable because it targets masculinity, precisely where uncertainty already lives quietly. But biology rarely behaves like rumors repeated loudly without understanding underlying molecular mechanisms properly. Here is the fracture in the myth: chemical in nature, uncomfortable, and deeply counterintuitive. Soy does not contain animal estrogen, the hormone that actively feminizes male tissues directly. Instead, it carries phytoestrogens, plant compounds evolved for defense, not hormonal domination within humans. These molecules resemble estrogen, just enough to knock cautiously on cellular receptor doors sometimes. Resemblance alone does not guarantee permission, authority, or identical consequences inside living systems everywhere. Your cells are guarded by receptors trained by evolution to discriminate signals ruthlessly daily. This is where fear collapses, because phytoestrogens do not behave like true estrogen biologically. They act as selective estrogen receptor modulators, negotiating influence rather than overwhelming pathways systemically. In certain contexts, they can even block stronger estrogenic signals already present internally there. You are not under hormonal attack, despite headlines screaming catastrophe from a single food. What you are witnessing is a misunderstood biochemical conversation amplified by cultural anxiety everywhere. Names mislead us, because estrogen sounds singular, absolute, and universally destructive to masculinity itself. Mechanisms tell a quieter story written in affinities, receptors, and context-dependent behavior everywhere. For now, suspend judgment, because fear is a terrible translator of endocrine language often. The real story begins when soy meets receptors inside your living tissues directly there. Nothing attacks you immediately, yet subtle negotiations begin without alarms or pain whatsoever initially. Understanding that negotiation separates panic-driven avoidance from intelligent biological strategy, long-term health. This opening door matters because the deeper machinery decides outcomes long before symptoms appear. And this is only the beginning of a story most men were never taught. What happens next will challenge beliefs reinforced by fear, marketing, and incomplete science narratives. Stay with the mechanism, because understanding replaces fear faster than avoidance ever could alone. Inside your body, estrogen is not one signal, but a language spoken through distinct receptors. Two primary receptors listen carefully, and they interpret similar molecular messages very differently internally. Think of them as offices receiving identical letters, yet responding with opposite internal policies. The first receptor, ER-alpha, behaves like a hoarder, obsessed with storing energy aggressively. When activated, ER-alpha encourages fat accumulation, tissue growth, and metabolic inefficiency under stress. This receptor dominates in adipose tissue and regions associated with unwanted feminizing outcomes patterns. The second receptor, ER-beta, behaves more like a structural engineer focused on long-term stability. ER-beta supports bone integrity, brain signaling, vascular health, and balanced prostate regulation processes. Both receptors bind estrogen, but their consequences could not be more different biologically here. This distinction matters more than any headline warning you about soy consumption ever has. Here is the critical detail fear ignores completely. Soy isoflavones strongly prefer ER-beta. Their affinity for ER-alpha is weak, partial, and far less biologically disruptive overall. This preference flips the narrative, transforming soy from hormonal attacker into selective communicator roles. Rather than flooding tissues with estrogenic force, soy whispers through protective pathways, preferentially instead. This is why context matters. because molecules behave differently depending on receptor environments present. But biology always includes thresholds, and fear often emerges where nuance gets ignored completely. Problems arise when soy stops being food and becomes an industrial extract product form. Soy protein, isolate, removes fiber, fermentation, and biological friction evolution expects naturally from foods. Now signals arrive concentrated, rapid, and stripped of buffering mechanisms completely inside human physiology. Receptors receive louder messages, and balance becomes harder to maintain over time internally consistently. This is endocrine disruption's true origin, not beans, but manufacturing shortcuts used widely today. Whole foods arrive with delay and negotiation built into digestion processes naturally over time. Isolates arrive, like shouting messengers, bypassing normal metabolic checkpoints, entirely inside the body's systems. Your body evolved expecting conversation, not chemical ambushes, without contextual safeguards in daily nutrition. Fear was not entirely wrong, only aimed at the wrong culprit, all along historically. Understanding this distinction separates biological literacy from nutritional superstition, reinforced socially over many decades. Next, the story descends deeper, beyond receptors, into the unseen world deciding hormonal fate. You begin eating soy foods cautiously, unaware that the most important decisions occur inside your gut microbiome. During the first week, nothing dramatic happens, yet microbial alliances are already shifting beneath awareness. Bloating and discomfort appear not as punishment, but as political resistance from unprepared digestive systems. Isoflavones travel intact into the intestine, waiting for resident bacteria to assign biological meaning. One compound, daidsine, becomes pivotal when certain microbes transform it into a stronger messenger. That messenger is Equol, a metabolite with greater receptor affinity and longer persistence biologically. Equol binds estrogen receptors confidently, altering downstream signaling more noticeably than its precursor molecule. Here lies the twist. Not every man possesses the microbial equipment required to produce Equol. Think of the gut as a factory with optional machinery installed long ago there. Some men own the Equol machine, while others never will, despite identical diets consumed. Roughly 30 to 50% of adults consistently generate Equol from soy exposure regularly. For these individuals, soy speaks louder because microbes amplify its hormonal accent inside bodies. Equol acts anti-androgenic, not destroying testosterone, but softening how strongly it signals downstream tissues. This modulation is subtle, gradual, and easily missed during short nutritional experiments by observers. Meanwhile, unfermented soy carries lectins and phytates, defensive compounds complicating mineral absorption within humans. Zinc suffers most, and zinc is indispensable for testosterone synthesis inside Leydig cells there. When zinc availability drops, testosterone does not crash, but production quietly underperforms over time. Fermentation changes the equation by dismantling anti-nutrients and recruiting microbes as cooperative partners instead. Foods like natto and tempeh arrive pre-negotiated, reducing digestive friction significantly for many people. Poorly prepared soy demands more adaptation, increasing discomfort in sensitive adult digestive systems globally. These sensations are feedback, signaling mismatch between food form and biological readiness within individuals. Your gut is not plumbing, but a decision-making arena shaping hormonal outcomes daily continually. Ignoring this feedback allows small deficiencies to accumulate invisibly, later masquerading as age or stress. Listening carefully grants leverage, letting you adjust preparation methods before hormonal consequences emerge fully. This is why identical diets produce wildly different outcomes across seemingly similar male bodies. Soy reveals individuality, forcing biology to declare differences culture prefers to ignore publicly often. Before blaming food, you must understand which internal translators are actually speaking inside you. Next, numbers replace sensations, as blood markers reveal whether fear aligns with measurable reality. By the third week, fear demands numbers, because stories collapse when blood markers speak clearly. This is where laboratories replace intuition, and hormones are measured without sympathy or cultural bias. A pivotal meta-analysis examined controlled clinical trials evaluating soy intake and male hormone responses. Led by Catherine Hamilton-Reeves, the analysis aggregated randomized interventions across diverse populations carefully. The findings were published in Fertility and Sterility, a journal known for reproductive rigor. 15 controlled trials measured total testosterone, free testosterone, estradiol, and related endocrine markers. The result unsettled internet certainty. Soy consumption did not reduce bioavailable testosterone in healthy men. Neither total testosterone nor free testosterone showed meaningful declines during sustained soy exposure periods. This conclusion contradicts fear because testosterone is regulated by feedback loops older than modern diets. The endocrine system prioritizes balance, adjusting production dynamically when binding proteins fluctuate slightly. One such protein, sex hormone-binding globulin, increases modestly in some soy interventions. SHBG behaves like a transport bus, temporarily binding testosterone without erasing its physiological availability. When SHBG rises, total testosterone may appear unchanged or slightly elevated on laboratory panels. Free testosterone remains stable because hypothalamic signals stimulate compensatory production to maintain equilibrium. This process is homeostasis, a biological thermostat indifferent to fear-driven nutritional narratives. Another quiet effect emerges. Soy phytoestrogens inhibit the enzyme 5-alpha reductase. This enzyme converts testosterone into dihydrotestosterone, a more potent androgen within specific tissues. Reduced DHT does not equal reduced testosterone, but it changes androgen pressure distribution subtly. Prostate tissue and hair follicles notice this shift more than muscle or libido systems. Lower DHT signaling correlates with reduced prostate stimulation and potentially lower pathological risk. This benefit arrives quietly, without dramatic sensations men typically associate with hormonal change. Here lies the paradox. Protection feels uneventful, while harm announces itself loudly in memory. Data therefore contradicts fear, showing preservation rather than erosion of male hormonal foundations. However, averages hide outliers, and biology never promises uniform responses across all individuals. Hormones operate within networks, not isolation, and another gland soon enters the narrative. The thyroid waits nearby, quietly setting metabolic rhythm that testosterone alone cannot override. This relationship introduces conditions where soy's neutrality can shift toward risk unexpectedly. Understanding that boundary requires caution, not panic, as the story tightens further. Testosterone never works alone because endocrine systems operate as alliances rather than independent hormonal soloists. The thyroid acts as testosterone's silent partner, setting metabolic rhythm that determines hormonal effectiveness everywhere. When thyroid output slows, energy drops, fat accumulates, and testosterone signaling weakens indirectly but reliably. Soy complicates this partnership through compounds called goitrogens, which interfere with thyroid hormone synthesis. Goitrogens inhibit thyroid peroxidase, the enzyme required to assemble iodine into functional thyroid hormones. Without sufficient iodine, this interference becomes significant because compensatory capacity disappears quickly from physiology. In iodine-sufficient adults, the thyroid adapts easily, absorbing soy without measurable functional decline. But adaptation fails when iodine intake is low or thyroid reserve is already compromised. Individuals with hypothyroidism live closer to this edge, where small disruptions cascade into systemic consequences. Over weeks, reduced thyroid output lowers metabolic rate, encouraging fat gain and inflammatory signaling. Fat tissue increases aromatase activity, quietly converting testosterone into estrogen behind the scenes. Now testosterone falls indirectly, not because soy attacked it, but because thyroid rhythm collapsed. This loop is subtle, slow, and often misdiagnosed as aging, stress, or unexplained decline. Clinical guidance from Mayo Clinic emphasizes iodine sufficiency for maintaining thyroid resilience. Another overlooked risk emerges when soy interferes with absorption of thyroid replacement medications. Timing matters greatly because soy consumed near dosing windows reduces levothyroxine bioavailability significantly. Patients experience fatigue and fog, blaming dosage changes, while food timing remains the saboteur. Then comes a red flag hiding in plain sight: refined soybean oil. Soybean oil concentrates linoleic acid, an omega-6 fat that promotes chronic inflammation. Inflammation suppresses Leydig cell output, undermining testosterone, regardless of protein intake or calories. If soybeans were judged only by soybean oil, fear would finally be justified. Whole soy behaves conditionally, while refined oils behave aggressively inside fragile endocrine terrain. This distinction separates caution from paranoia and precision from blanket dietary avoidance. Soy becomes risky, not by presence, but by context, preparation, and metabolic vulnerability. For men with thyroid disease, soy demands structure, spacing, and nutritional awareness. Ignore these boundaries, and benefits invert into liabilities without dramatic early warning signals. Yet, absolutism creates different harms because unnecessary restriction erodes dietary flexibility over time. The goal is not avoidance, but informed engagement with biological limits clearly understood. Next comes resolution, where understanding restores agency rather than replacing fear with restriction. After 30 days, the experiment ends not with collapse, but with clarity earned through biological observation. Your testosterone was not fragile glass shattered by a bean, but a regulated system defending balance. When soy appeared as whole food, hormones adapted, negotiated, and preserved functional equilibrium quietly. When soy appeared as oil, isolate, or industrial shortcut, systems strained and signals blurred dangerously. The difference was never masculinity itself, but context, preparation, micronutrients, and biological literacy combined. Fermented soy reduced anti-nutrients, supported microbes, and softened hormonal messaging across sensitive tissues. Unfermented excess removed friction, overwhelmed clearance, and exposed weaknesses already present beneath the surface. If iodine and zinc were sufficient, thyroid and testes cooperated instead of entering metabolic conflict. If those foundations were missing, soy revealed problems rather than creating them independently. This reframes the fear entirely. Soy is not a poison, but a diagnostic stressor. It exposes dietary gaps, microbial differences, and endocrine resilience without dramatic symptoms initially. Used intelligently, soy can support prostate health, lipid balance, and metabolic signaling efficiency. Used carelessly, it amplifies inflammation, mineral depletion, and hormonal confusion through indirect pathways. The tool is neutral, but the hand using it determines the final biological outcome. Here is the uncomfortable question most men avoid confronting honestly after hearing this evidence. Did soy actually damage your hormones, or did it expose vulnerabilities you already carried? Some men swear soy destroyed their drive, confidence, and strength within weeks of consumption. Others eat soy for decades and maintain stable hormones, vitality, and metabolic health. Both experiences exist, which means simplistic answers are intellectually lazy and biologically incorrect. So tell me below what actually happened when you personally ate soy consistently for weeks. Did digestion shift, energy change, libido fluctuate, or nothing noticeable happen at all? Share your experience in the comments, because patterns emerge only when individuals speak honestly. Your story may help another man decode signals he has been misinterpreting for years. Masculinity is not destroyed by phytoestrogens, but ignorance destroys adaptability over time. Your biology is ancient, resilient, and strategic, not easily fooled by a single food. Health is not punishment for mistakes, but intelligence applied repeatedly under imperfect conditions. Soy does not decide who you become. Your understanding decides how it affects you. Listen carefully, because no study is more precise than sustained attention to your own system. That is not anti-science, but its most personal and demanding application.